Understand? Oh, okay. Hi, hi, hello everyone. Okay, so this is what we are going to do today. I hope and I understand and I am assuming that all of us know the importance of the ER diagram by now, and the idea that this channel or what we are doing here mainly is about making those details, right? It's about doing those details. Then let's get this done today. All right. So, in an entity relationship diagram, there are blocks which would be entities. Okay, there are attributes of different types and their relations. We'll see all of it in some time over on this side. Let's use yellow for entities and green for attributes, and let's say blue for relationships. Okay, and let's create kind of a relationship for where we would get everything we need, right? Maybe a student, course, teacher, or classroom kind of thing. But let's use two different things for that matter. Okay, let's say this is an entity, student. Okay, entities are represented by a rectangular box. It could be square also, it's up to you, but generally rectangular. We have course, and this is the relation. Now, to represent the relation in between, we will go and make something different. We will make a rhombus. This is a rhombus, a kite-like structure, which is called a relation between the two entities. Now, this relation is made specific by the cardinality, as I said before. Now, you can use the crow's foot notation over here. Now, this is many, and this symbol is one or one, like this, right? Or you can just write m. You know, it's a many to many relation. That's all. So entities like that and relation like this. Okay, let's do a school and classroom relation. Okay, that's too big of a box. School. Okay, and let's say we'll make that later on. Now this is called a weak entity. I know we have covered weak entity before. Okay, and this is how it's represented. Rectangle inside rectangle, and I'll make this has. Okay, and we'll just say one school has many classrooms or classes. Okay, now attributes. These are the only two kind of entities that we have: a strong entity and a weak entity. That's it. Okay, a strong and a weak entity. Let's go for attributes and see what kind of attributes will these things have. A school will have a name. Now, an attribute is given by this oval or parabola kind of thing over here, right? A circular kind of thing. School will have an ID. This dash underline you can see is saying that this is a key attribute. Okay, like a primary key or a foreign key, something like that. A school will have name, ID, as this is which is the key attribute. It might have another things like address. Now let's say an address is a composite attribute. That means address contains of other things. That means then it will branch out like this. Let's say street. Okay, state. Okay, and we have pin code, and go like that. Let's say a student would have a ID again, right? They would have a name, right? They would have a phone number, let's say. Now this double thing is saying that it could be a multi-valued attribute. There could be multiple phone numbers. Multiple phone numbers there could be. Then that's how it is. A single ellipse or no, it's not parable, it's ellipse. A single ellipse attribute, an ellipse with the ID, with the name of the attribute, and a dash or underlined attribute. Name would be key attribute, foreign key or primary key or any kind of key like that. Then a double ellipse would be a multi-valued attribute. Now there's one more. Let's say this relation is the third table that we have, right? Let's say this relation has an attribute called score, okay, of the students based on the subject, and then there can be a attribute like that called percentage, let's say, okay, which is denoted by a dashed or a dotted ellipse or a dashed ellipse, which is known as a derived attribute. Derived attributes are not given value at all. Maybe you can, through triggers or any other like procedures or something, you can give them the value by calculating through the other attributes. Like the score would be like the percentage would be score divided by 100, etc., like that. Okay, that's how the attributes work. These are the four kind of attributes. All right: normal, key, multi-valued, oh, and derived. That's all four are covered. Okay, then relations are simply denoted by this rhombus that you see. Between anything, between any two entities, there'd be a relation like this, and the only thing that you have to take care of are the cardinalities. One is a one to one, one m is one to many, m is many to many, in which case you will have to create a third entity which will be connected to it, which would be the relation table, literally. Okay, and I think that's all. Now there are one more thing. I think in through relation only, let's see that. Let's say this is the relation and this is a notation that we have. Now this depicts a total participation, right? And this is a partial participation. We have talked about this before. You can check out those videos. Total participation simply means that there at least should be one from this entity over here connecting with multiple entities over here. Okay, a partial participation simply means even if there is one, it doesn't matter. There could be entities over here which are not connected with anything over here. Okay, so even if it is one, it could be zero. There's no, or you can say, actually that's the wrong explanation, to be honest. Even if there is one over here, but to its corresponding there's nothing in here, there's no row in this table for that, that's a partial participation. You can see a detailed video. I think I'm doing some mistake over here right now, but you can see the detailed video on that we have created before. Other than that, I think there's one more notation that I remember, if I am right, about a weak relation, but I have not seen it being used anywhere. But I think that's it for the video. These things you will see everywhere, and from these things you can create these notations, you can create a normal ER diagram which can help you create better solutions, better understand, which can give you a representational better understanding of the database that you are going to create, and through these you can maybe create a better solution. We will see more problems later on where we will actually draw the entity relation ER diagram that we have, right? And maybe try to learn from different mistakes that we make or understand how it works. Thank you for your time, and let me know if you have any questions or queries. Goodbye.